Some more fun with exponent rules. Here we're going to look at fractions and negatives together as exponents or powers or indices, however you want to call them. So just to remind us of our basic rules that we've just been covering for negative and fractional exponents. So here if I have a negative power and I'm on the top, it becomes a positive power on the bottom. If you have a fraction with a negative power, you can flip the fraction over and have the positive power, making sure you flip it. With a fractional power, remembering that the number or the variable on the bottom of the fraction, the denominator, becomes the order of the root, or the size of the root there, the 8th root in that case. If you have a fraction that does not have a 1 on the top, you've got that b, the power or the number on the top of the fraction becomes the power inside, the exponent inside, and the a still on the bottom becomes the size of the root or the order of the root. Now if we apply that with negatives, same idea. If you have a negative 1 over a, we get this idea that it flips upside down. You now have a 1 on top because it was negative, and you still have the 8th root in there because the a was on the bottom of the fraction. Taking a look at the next rule here again, if you have a negative power, it means I'm going to flip things upside down, or put them under with a 1 anyways, and the a on the bottom of the fraction will still be the size of the root, or the order of the root, and the b at the top there will still be the power on whatever is inside of the root. So, let's take a look at some examples. Applying these together. The first one I'm looking at is 81 over 25 to the power of negative 1/2. So you can think about this with the negatives first if you like. That might be a nice way to do it. Again, because this is a fraction, I can flip it upside down. So I have 25 over 81 to the power that is now positive 1/2. And remembering that the positive 1/2, that's the same as saying 25 square root over 81 square root. And in this case, the square root of 25 becomes 5, and the square root of 81 becomes 9. That's our final answer. So again, because it was a negative power, I was able to flip the original fraction, and then from there it became a positive power. And knowing that a half is the same as the square root, I was able to simplify it from there. Taking a look at another similar example here, this idea that we've got a third root, and it is negative, so I can think about flipping that first. 64 over 27 to the power of 1/3. And if we go about that, knowing that to the power of 1/3 means the third root of both of those things, third root of 64 over the third root of 27. Well, what times itself 3 times gets it to 64? 4 times 4 is 16, times 4 is 64. So I've got 4 there, and on the bottom, 3 times 3 is 9, times 3 is 27. So I have 3 on the bottom, and there's my final answer. If you want to, you can stop writing it and showing the root, and you can just go straight to the answer once you know that a third means a third root, and you don't have to write it out, that's fine. But if it helps you to write that out, and same here, I could have just gone from the power of 1/2 straight to the 5 over 9, not having to write out that square root step there if you don't want to. Another example, 5 over 2, and it is to the negative power here, so I'm going to flip it first. 2 over 5 is now to the power of, not flipping the power, just flipping the fraction itself, is now to a positive power, 2 over 3. A couple of things that need to happen here, and I'm not sure how they'll work out, but that 1/3 there is saying this needs to be a third root, and that 2 means that I need to square. So, it might be helpful in this example to actually write it out. So let's see that we've got a 2 to the third root that's squared, all over a 5 to the third root that is squared. And we can simplify on the inside because that is a number we can actually figure out, and that's going to become the third root of 4, 2 squared is 4, divided by the third root of 25. Now remember, the third root of 4 is not 2. It's going to be something else. It's going to be a decimal, and I'm not able to figure that out without a calculator. So you could feel free to leave it in that form. As another example though, you could just write that out as the one giant third root there, You don't have to have a separate one for the top and the bottom. You can just write it as one giant third root with that fraction 4 over 25 underneath. Alright, next example. The fraction m over p to the power of negative 2/5. Again, I see that's a negative, so I'm going to flip over this fraction, but it's not the power fraction that flips, it's just the base here. That becomes p over m, and I'm now with a positive instead of a negative fraction, 2 over 5. And that's probably okay to leave it like that if you just wanted to get rid of the negative power. But if you wanted to know what that looks like as a root as well, that would be the 5th root, because the 5 is on bottom, of p squared over m squared is another way you could write that problem. Taking a look at the next example, x to the power of 4, all of that to the power of negative 1/2. Now remember, I've got brackets here, so we can kind of play with this a little bit. When you've got an exponent outside a set of brackets, remember you need to times whatever the power is outside to the powers inside. So if I times that, that becomes x. What's 4 times negative 1/2 becomes negative 2. And that becomes 1 over x squared. A couple of ways to visualize that if you wanted to as well. We could have written that as 1 over, because it's a negative and I'm going to put it underneath, and because it's 1/2 I know it's the square root of x to the power of 4. And I know that if I'm taking the square root of powers, I can have them, and that is because I'm timesing the 1/2 by it, basically, but now you can see another way that it gets there. So, my final answer there becomes 1 over x squared. And I guess just as a little side example there, if I had something like x to the power of 7 to the 1/3, you can just write that as x to the 7 thirds, and keeping in mind that that is the third root of x to the 7 as well. So you can have a play with those numbers like that, with the power rules. Last example here, 2 to the power of negative 3 over x. Again, it's a negative power, so I could think about inverting this or having the reciprocal. So I might do 1 over 2, and that is going to be the power of 3 over x. So I know my 3 is going to be the power inside on the 2, and the x is going to be the order of the root. I don't know what it is, so I'll just put x. And I can simplify this a little bit further because I know 2 to the power of 3 is 8. So I might say 1 over the x root of 8 as my final answer. So take your time with these as you're getting familiar with it, and think through it really carefully, making sure that you're paying attention to what you can do with negatives, and just see if you can simplify things at the end as well.